I have a very soft voice and a French accent, so you'll excuse me. So today I'll discuss a little bit about the place of middleware in the world of mobile and cloud computing. And briefly, I will also talk a little bit about what happened. The time have changed a lot in the last 20, 30 years. And I'd like to discuss a little bit of what happened until the mobile and cloud era today. There are a number of hardware and software forces in action. We're going to talk a little bit also about the different paradigm and also the enterprise Java. How does it fit? Is it ready? Are you ready to develop on the mobile and cloud? We'll talk about also standards. I think there's a emerging standard or non-existing standard, and how open source actually help these standards to mature and to be adopted. So I don't know if you can see here, but probably some of you makes me old, but I started to develop on the Z80 in writing assembly language, and also on Motorola, all type of 8-bit processors. And if you look at these processors, they have evolved not only in size, but also in quantity. Today, there's about 4 times more processors than there's actually people on the planet. The size, also the cost. Here, I think these microprocessors can process as much as a VAX machine and even more, from 40 MIPS to 60 MIPS. They can address 32 bits of memory. And they're also networkable. They have TCP stack. So that means that you can connect. They can connect also to other devices. So there's a huge difference from what we saw about in the late 80s and even before that. Today we see also upcoming of new type of devices that can work offline, also connected between them. We have today over 300 million iOS devices, 500,000 Android phones are shipped every day, and millions of apps and billions of downloads. So the world is definitely changing. We have and it's no surprise to you all. I think most of you, and I know some of the people I met earlier at lunchtime, we've been in the industry at least for 20 years, and this is an amazing change. Where do you find these processors? They're everywhere. They're in your camera. They're probably in that device. They're also in cars and your fridge, probably. So they're basically everywhere. It's not just on a PC or a laptop or a mainframe. They are everywhere. And this is where you develop your application and deploy your application. I talk about density and also weight and processing power and cost. Here you see a very good example of where we are today. Even though the previous microcontroller probably cost around $1.50, this full, basically a PC, that's the size of my hand, called the Raspberry Pi, that will run any Linux flavors with some Java, Python application, is about $25, okay? And also networkable. You can have a HDMI output, USB. So you have a lot of power, and you have it in your pocket. You have it on, your phone and your tablets. So there is a law actually from Parkinson. I don't know if you know it. It's basically it says it's very true today in today's world is that the work you have will expand to the amount of the available time you have. It's the same here. So the work expands to use the power available. It's true, but not everywhere. If you look at some of tablets, I have some at home also. Very often, people use it just to browse. We don't fully utilize the power of our tablets. However, games, starting from Pong to Space Invaders and Call of Duty, all these games actually fully utilize these devices. I don't know if you have Angry Birds. Definitely will work offline and fully utilize the processing power and the memory you have on your device. Otherwise, if we were just thin clients to browse the web, we should have stopped that earlier. Okay, so the norm is actually to work in disconnected operation. That's the normal situations. We also have this device capable to do near-field computing, so you can actually swipe your device to do some payments. We also have a very large, the norm is actually also at least 1 gigabyte of memory plus about 64 gig of storage. So you can put many years of your photography of all your families just on one device. So I think it's definitely expanding to take all the available power we have. Application complexity also has increased. I think if you look at especially where the norm in disconnected is to be disconnected, I know very well by traveling that if you have a thin client on your pad or on your phone, that's a problem. Unless you're willing to pay enormous charges of roaming, I think we have to look at in this peer-to-peer interaction very seriously how to leverage the power of your device as opposed to rely on the cloud and only online functionalities. I'll talk a little bit also about enterprise requirements. There are security and identity that are very dominant in the industry. Today, there is a recent report that says the cost of identity theft is actually 4 times more than the global drug trade. So we hear about it in every country, and that is predominantly on the mobile interactions, yeah, and online payments. High performance, low latency, reliable messaging. These have been in the industry and grow and matured over the last 30, 40 years for some of these concerns. Database updates with transactions also are even more important, especially when you do payments, when you do a number of transactions online, in-app payments. We take all these things for granted, but they are very important in today's computing. So if you look at the way now pads and devices work, we have a number of social networks that as a work offline or with online capabilities. We also see some research in what we call the social and 2.0, which will basically, if you take Facebook, for example, all your data is maintained and held in one place. Some research is actually to take that data away from these monopoly, like Facebook, who actually control your data and do whatever they want based on what you read or do not read in the terms of agreements. And here we're trying to actually put the data you want to share only on your device, not on someone else's database. We've seen also the tablets displacing the consoles. I have my kids usually fighting over my devices, so it's almost impossible for me to get hold of them. I have to use my laptop, and even though I could do the same work on my tablet. So we see more and more the tablets and these devices displacing consoles. I don't know if any of you have used the public cloud. Amazon has been there for a long time, but cloud is not new. I think there is a number of attempts, and one of the first one I'm aware of was in the early 2000s, Loud Cloud, with Mark Andreessen, the founder of one of the first browsers, and Netscape. Here we already had in Loud Cloud the ability to burst in terms of database, application server, and also network bursting capabilities. So that was primarily, it was not multi-tenancy, definitely not. It was really a server more or less dedicated, but the concept existed a long time ago. We moved with Amazon to actually a more rental model and public cloud offering. But I think the private cloud, as we see it, and the report says that actually it's probably the area where we see a lot of growth, especially with virtualization has been there for a long time. You see it not only at VMware, but Solaris zoning and other technologies that allow that for a long time. Okay, so I mentioned earlier that thin clients are not sufficient anymore. If you bet everything on just doing HTML5-based mobile applications. If you look at the, I don't know if you know Shannon's limit, but there is upper limit on the bandwidth. The cloud works today, but definitely not in the future if we bet all our workload on the servers, on the cloud, and just relying on thin devices, thin clients to access it. So we have a lot of power on these devices, which were equivalent to VAXs 20, 30 years ago. And apart from games, we need to leverage that, okay? So that's an opportunity. So there is a number of devices, not only smartphones and tablets, but field services, things that works in as a connected or disconnected operations. Some will have TCP stack, or some that don't have TCP stack, but still can provide data through proxying. Okay. New edge development. So very often, even myself, when I start a new project, I tend to rewrite things that exist already. But I think that's a big mistake in many occasions. New implementation, they want, in the in the 60s, there was this era where everything was bad. We had to do everything again. And in our case, do we want to write new frameworks, new operating system, new security, new transactions? I think that's the big mistake. We have actually a matured, many platforms, many, especially EE actually has already mature with the EE6 actually mature to a level where it's very, very easy to implement transactions, security, etc. in a very efficient way. So definitely middleware is not dead. Remember, web services and REST, people were predicting the death of middleware, but definitely not. If you look at it objectively, RPC was in first used in the 70s to link Unix systems, and then we've seen the emergence of, like Arjuna, for example, that JBoss acquired is one transaction servers with about 20 years at least of maturity. And the standards also evolve, NSA, DCE, and also vendors. So we are the 6th generation of EE today. We're planning the 7th generation. And I think Arun Gupta and Mike Heath already have addressed that today, and we'll have other sessions on the subject. So these 40 years of middleware show that we understand and master security, messaging, distributed transaction, replication, caching, database. We'll talk a little bit about database because alongside with multi-tenancy, this is an area where we need to develop at the JVM level. So there is 40 years of experience that designing enterprise infrastructure, and we very often take that for granted, but do not rewrite it. So trust is important. I mentioned, the identity theft issue, also the different quality of service, the level of availability, the SLA you want to put in place. These are computing realities that are even more important in the cloud world. So what does that mean? So middleware is needed whatever deployment environment. So now when we build an applications, like at JBoss, we actually, with the seventh release of the application server, we took into consideration all these deployment environments, so different targets, whether we deploy on a mainframe, whether we deploy on a mobile, and we also demonstrated at JBoss World last year. We actually deployed on this small plug PC and created a data grid with distributed cache on it, just with an app server that's a very small footprint and is also standards, EE6 standard. Okay, so but don't want to tie the definition of middleware to a specific implementation. That's definitely some concerns that are addressed in many implementations. But ignoring what happened before and trying to do yourself, these things will definitely be totally inefficient, expensive, and time-consuming. So definitely the middleware is here to stay. That means you and I will have a job for a long time. And obviously, Java is not the only application, only language. We also looked at Clojure, Scala, and other JVM languages that are actually emerging, and we also introduce them and support them in our new runtime. So I think this is an area of where we see a lot of growth. So E6 turned out to be definitely a very good evolution if you compare it especially to E5 and the previous one. I think that basically a great evolution and assembly of lots of work and capabilities. We have REST, CDI for developer productivity, bin validations for people who were worried about, where to put the validation at the backend level, at the front end in your JavaScript, or at the object level. So we solve a lot of these computing issues, and E6, I think, is a very mature platform to develop. Okay. So I'm not going to talk too much about JBoss product, but I think we've actually have a session later on that where AS7 actually is one of what we call runtimes that are cloud ready, because you can't put the existing, the one we had before were extremely heavy. Well, extremely heavy was still okay, but when you want to deploy and to have capacity and density on the cloud, these are concerns. So you want to have a very small footprint, very fast bootstrap time, and extremely capable and concurrent algorithm to deploy and resolve some dependencies on your application server. So I was talking to Mike earlier. We have some work around JCP has been reinvigorating. Let's benefit cloud and mobile. So we take, the process with, it's a new process, JSR, which is a lot more open, allowed to have actually input from a lot of, not outside the EC itself. So it's a very, very great advancement. So we also have merger of Java ME and SE with at the expert committee level. I don't know what's next. I think we probably address that in the next sessions with people from Oracle. Java PaaS, of course, there is a number of non-standard solutions. I think we see that evolving, and with the adoption of middleware through a different stack and providers, I think you see the world of cloud and PaaS moving at a fast pace, and I think there's a big pie to share, and I think hopefully we'll get some evolution there. But don't standardize too early. I think open source is a good driver for that, and we see a lots of good feedback today. So there's many areas of middleware should focus. I think resource sharing. I'll talk about multi-tenancy earlier. I think E7, hopefully that Oracle will address later. We'll go into a little bit more detail of that. Replication in the large also. You saw probably some sessions on NoSQL, NewSQL, etc., Old SQL. So we can just quickly browse through those because we're running out of time. But PaaS require high density. I mentioned earlier runtimes that are very thin, very small bootstrap, and leverage some capabilities like multi-tenancy. So you want to run basically multiple applications on the same JVM, or multiple app server also on the same JVM, multiple applications on these app servers. Okay. So what's needed here is basically, I think we need more language to move in that ecosystem. We have capabilities of multiprocessors per JVM, some real-time capabilities, low memory management, like also Google VM is doing. So this is the area where we need to put some effort to. Replications, many people, I met some people recently in Hong Kong, and they use traditional relational databases, and it's a big issue now. We have so much data. Lots of banks and other government bodies have data retention policy that's very, very, very long, like 20 or 20 years, depends on each countries. But that means that you have to capture and keep that data, still be able to run some reports. Still, you still want to have things like fault tolerance, analysis and real-time analysis and updates on some data sets that are the size of terabyte. We've seen also with the social networking. So this actually resulted in various number of SQL database flavor. Old SQL as we know it today, or not only SQL, which I think we have few sessions, and Manik mentioned some of those in his talk today, and NewSQL. NewSQL is also an area where existing vendors are investing because they realize that they can't provide these capabilities with today's days. They know their limits, and they have to address that. We've seen also some research institute who prove that with this new NewSQL database, you can reach about 60 times the efficiency compared to the traditional RDBMS. for the interest of time, I will skip on that, but again, NoSQL and the other properties from RDBMS, there is still a gap between them. We need to relax some of the RDBMS properties, like ACID properties. We need also to look at, how do you do support transaction, distributed caching, etc. Just before I finish, I don't know if everyone knows Richard Hamming in the Turing speech, where he mentioned when Newton said, if I have seen a little farther than others, it's because I have stood on the shoulders of giants. But in computing today, we mostly stand on each other's feet. Perhaps the central problem we face all in the computer science is how we are to get to the situation where we build on top of the work of others rather than redoing so much in a trivially different way. So I mentioned earlier, it's very important that the cloud and mobile will evolve if we actually share the middleware component that we've been working together with other communities and look at what they need, and so they don't have to spend reinvent the wheel and these concerns we've been working for the last 30 to 40 years. And next decade we'll define ubiquitous computing, and there's still areas that needs to be addressed, as I mentioned, around multi-tenancy, etc. So I think today you have, I think in 2012 we called it the year of the developer. I think it's very important when you understand these concerns that there's a lot of work to do. So there's a lot of opportunities out there. There's lots of power in your pockets and potentially lots of money in your bank account if you understand the right problem to solve. So I wish you good luck, and thanks for attending this session. Thank you.